Hello and welcome to video 2B. And in this video, we're going to discuss what we call special right triangles. And there are two kinds that we are going to have you work with. They are called the 45, 45, 90 and the 30, 60, 90 based on their angle measures. So let's chop this concept box into two pieces. In the left-hand side, we're going to discuss the 45 degree, 45 degree, 90 degree triangle. So what I want you to do is draw one of those. And if it's 45, 45, 90, I'm going to go off to the side here. Watch when I take a square, which is 90, 90, 90, 90. All the sides are the same length. And when I chop that square in half, I would get then 45 cut in half. 90 cut in half is 45. So I get this left-hand side that I call a 45, 45, 90 right triangle. And that left-hand side of the square is what I'd like you to sketch right below here. Put a 90-degree box in there. Put a 45-degree angle down here and a 45-degree one up here. Now, we're going to be looking for missing parts on these. And right here, you'll notice because it's half of a square, these are equal lengths. If this is 8, this is 8. So up here, we're going to put an X on this and an X on here. The sides, or the two adjacent, or the legs, the ones touching the right angle, are always equal. So if you're given one of them, the other one comes for free. So if you were given that this one is 3, this one's also 3. Well, the question becomes, what's the hypotenuse? Watch me solve for it with the Pythagorean theorem, and then we'll never do that again, because the same thing always happens. And that's why we have shortcuts, and that's why they're called special right triangles. If I said a squared plus b squared equals c squared on this one, I would have 9 plus 9 equals c squared. Again, you don't have to write this stuff down. Just watch it closely. 9 plus 9 is 18. So taking the square root of both sides gives me root 18 is equal to c. But you'll notice that 18 has a 9 hiding in it. So if I pull that 9 out, I get 3 root 2 for the hypotenuse length. Well, go up here. When the leg was 3 and the leg was 3, I got 3 root 2 over here. That's going to happen no matter what leg length I'm given, because I will always have 2 of these. So it's always going to boil down to that same situation. So we can always say that this is equal to x times the square root of 2. And then you're able to work with them. Now, the question becomes, how do I know if I multiply or divide or what have you? I'm going to put another one on here. And I'm going to suppose that I was given this being 5. And I told you this was a 45, 45, 90 right triangle. Then this is 5. Then what's this over here? It's 5 root 2. You might say, is it that easy? It can be. But what if, I'm going to go erase this. You can just keep that one in your notes. What if I was given this? The question becomes, how do I go from this one back to this one? Well, if you multiply x by root 2 to get the longer side, then when you have the longer side and want to go back to the shorter, you divide. And this I would write on your notes, because remember, you can use your notes on the test. You divide by root 2. So for me to go from longer back to short, I need to do 10 divided by the square root of 2. And technically you could leave that, but we're going to rationalize the denominator for this. And remember to do that from your other math classes, both exponential algebra and geometry semester 1. To rationalize the denominator, you multiply the top and the bottom by the root on the bottom. And what you get is 10 times the square root of 2 on the top over root 2. Well, root 2 is 4, which is just 2, or you could think of it as root 2 squared, and the squaring undoes the root, but I end up with 5 root 2 over here. Well, then what's this thing? It's also 5 root 2, so we can walk our way around those triangles. For the 30, 60, 90, there's relationships that hold as well, and what they allow you to do is very little work to find missing sides. Well, for the 30, 60, 90, let's go draw one. Go like that, and like that. For the 30, 60, 90, you have very clearly a 90-degree angle, and then this will get labeled as 30. It's the smaller of the two. And what it all revolves around for the 30, 60, 90 is the short side. So I want you to really bold that in. The shorter side is the one you need. If you don't have it, you need to find it. And that becomes the question, how do I find it? Now, I would like to call that X, but I think that's going to goof you up. So I'm going to call it S for short side, but make sure your S does not look like a 5. When I have the short side, the hypotenuse is always twice the short side. That should make sense to you because if again, I'm going to go off onto this workspace here. I like to sort of try to explain where things come from. If I have this short side on the 30, 60, 90, and then if I were to extend this, then what I'd have is a 60, 60, 60, or an equilateral triangle. So this becomes twice the short side, and so does this. Oopsie. So does this, and so does this, because all the sides on an equilateral are equal. This side, if you were to do the Pythagorean theorem on the other two, which I'm not going to for time purposes, becomes short side square root times the square root of 3. So if you know the short side, you double it to get the hypotenuse, and multiply by root 3 to get the long. Now, if you're given one of the other two, and not the short side, then to go back this way, you're going to need to divide by root 3. Or if you're given this one, you're going to need to divide by 2. So if it's getting longer, we multiply. If we're going shorter, we divide. Let's go practice. So here I've got a 45, 45, 90, and I'm given the hypotenuse, the longer side. I know these are equal, but I don't know what they are. Well, what I do know is that what I wrote up on that other one, that to go back, you need to divide by root 2. So whatever y is, it's 4 divided by root 2, and that's going to be x, and it's going to be y, because these legs are the same, because this is really half of a square. Now, 4 divided by root 2 technically is considered bad grammar in math. You're supposed to do what we call get the root off the bottom, or rationalize the denominator. To do that, you multiply the top and the bottom by the root on the bottom. This is technically 1. So you're not changing the value. Anything over itself is 1. So that blue fraction is really 1. So I'm not changing the value of my fraction. I'm just giving it a facelift. So on the top, when I multiply, I get 4 times the square root of 2. On the bottom, root 2 times root 2 is root 2 squared, or you might want to think of it as root 4, but either way it's 2. And you can see that these two now cancel. So my answer is 2 root 2 for both x and y. Now on this next one, I've got the 30, 60, 90. You might say, well, how do you know? Well, because I know that the angles in a triangle have to add up to 180 degrees. So if one's 90 and one's 60, the other one has to be 30. Remember I told you that these all revolve around the short side. So when you get your worksheet, I want you to, on all the 30, 60, 90 ones, I want you to really bold in that short side. That's what you need. How do you get it? Well, I was given the hypotenuse, which is twice the short side. Again, you're going to really be referring to that concept box that we made up at the top. I have the hypotenuse, which is twice the short length, which means this short length had to be 5. Just divide by 2. Now, when I go from the short length to the longer length, because again, we call this short, long, hypotenuse. You'll notice in the concept box I said you multiply the short by the square root of 3. And you can just walk your way around that, never having to use the Pythagorean theorem. I'm going to give you another one of those. So let me put another 30, 60, 90 on here. And let's suppose for this one, this is 30, the smallest angle, and 60. Let's suppose I gave you the short side and I said, hey, guess what? The short side's 7. Well, the short side's the one you want because then you just double it to get the hypotenuse and multiply it by root 3 to get the long side. Easy peasy, mac and cheesy. The problem is, again, when you're not given that short side. So let's pretend that I was given, and again, let's call this 60, this 30, and I always want this short side. If you're given it, super. If you're given the hypotenuse, divide it by root 2. The hardest case is if they give you the long side. To go from long to short, you need to divide by root 3. But then we rationalize the denominator. So we multiply the top and the bottom by the root on the bottom. And we get 9 root 3 over 3. Again, 9 root 3, multiply that way, and root 3 times root 3 is root 9, or root 3 squared, which is just 3. And then these cancel. So this is 3 root 3. Once I have the short side, look in the concept box, the hypotenuse is twice the short side. So I double my short side, giving me 6 root 3. This is a hard section for most kids, and it's because they don't want to follow the map. They just want to look at it and know. You're going to have to use those relationships sometimes. So now in 2.4, we're still going to be working with special right triangles, but they're going to have multiple steps. So we're going to have to walk our way around. What am I given? And where do I need to go? So somehow I have to make a jump from this triangle to this triangle. Well, let's go look at what I'm given. I've got a length of 7 on a 45, 45, 90. And these are the legs. The legs on the 45, 45, 90 are congruent. So that walks me over here. The hypotenuse on the 45, 45, 90 is leg times the square root of 2. And that walks me over to the next triangle. Now I'm on another 45, 45, and I'm given a leg. So I know the other leg is the same. The hypotenuse, which is x, is equal to the leg, right here, times root 2. And again, use that concept box on the top of the other page. It says for the 45, 45, 90, x times the square root of 2. So x times the square root of 2. And again, let's call that c maybe otherwise you're going to be goofing up the x and the x. What is root 2 times root 2? It's root 2 squared, which is just 2. Or if you like to think of it as root 4, it's still just 2. So this is 7 times 2, which is 14. And I've walked my way around that right triangle conglomeration up there. So now again, I've got another embedded right triangle inside another right triangle. They have 60 degrees in them, so I know that the other two smaller ones are 30 degrees. Let's start with what I know and walk my way to the other one. This is the short side of the 30, 60, 90, which is my favorite to get. Because once I know the short side, again, you should go look at that concept box. Whoopsie, let's make a neater one. In the concept box on the previous page, we said once you know the short, hypotenuse is twice the short, long is short times the square root of 3. So let's go apply that. It's like a map. Follow the map. Hypotenuse is twice the short. The long side is short times the square root of 3. And you might be saying, but that's not what I want. No, but at least it allowed you to hop on and get started in the triangle that has the missing piece in it. Well, again, I'm on another 30, 60, 90, but fortunately, I'm on the short side again, and I like the short side. To get to the hypotenuse over here, I double it. But that's not what I want. I want the long side. All right, so it's short, 10 root 3 times square root 3, which is equal to 10 times root 3 squared, which is 3, or root 9 if you prefer, which is still 3. And it gives me a side of 30. For this two sections, these are really important and they're all over the ACT. They're all over Algebra 2 and higher levels of math. So I'm going to have you do all of them on worksheet 2.3 and 2.4, and I am not going to allow you to access this test until I'm pretty confident that you can do those at a passing rate. Have a good one.